Welcome to another chem lecture from me. We'll be going into things that are review for you that should go quickly. A couple of things I want to mention. One, you have a chem portfolio, so you need to make sure you take notes, and vocabulary is important because you need that vocabulary in the glossary of your portfolio. So make sure you take notes of this. Secondly, these videos are designed so that you can do your project that's coming up a little bit easier, so that you're not stuck. Now, not all of you are going to have all this information, but you will need all this information for later. Chem builds on itself, so you need to make sure you know this. I'm going to fly right through it. It should be stuff you already know. Starting with states of matter. So there are 4 states of matter. Actually, there are 5 now, but 4 we're going to cover. The 5th one someone's going to do in their project. So the 4 are solid, liquid, gas, plasma. The 5th one is where sand falls in. It's not quite a solid, it's not quite a liquid, but that's where the 5th one is, and I'm not going to talk about the 5th one because I want someone else to do it in their project. So you have solid, liquid, gas, plasma. So we're going to go through those real quick. This is a solid. Remember, it has its own shape, has its own volume. So that's a solid, very rigid most times. We'll get into how the particles look and how they move. Liquid looks like this. I shouldn't have to go through this. Takes the shape of the container, has its own volume. And gas, which if I can do this correctly, let's see if I can do this correct. So you have gas that's coming off of the flame. So gas is, if I go like this, you'll see it dissipate. You can see the glass on the edge, and there's your gas. You can see all that gas. And gas does not have a shape, does not have a volume of its own. So it's all over the place. And the 4th one is plasma, which you see in stars. I can't just rip a star down and say, here you go. But plasma you usually see out in space. It's that ionized electrons and protons, so the plus and the negative charges. So you see it in lightning, you see it in the stars. Most of plasma of what we see is out in space, not typically here on Earth. So a good chunk, like 90% of plasma, is found out in space. So now we're going to talk about how those particles move. So we're going to start with solid first. So solids, remember, are really tight. Those particles are really tight, close together. So if I was a solid particle, this would be my space, and I can't move that much. This is all I get to do. I just get to vibrate in place really fast, but I don't get to do anything else. I don't have the luxury of going anywhere else. So as a solid, I just vibrate a little. I don't get to move all that much. Now as a liquid, I get a little bit more space, and I move a little bit more than a solid. So here's my space as a liquid, and I'll bounce here, and then I'll bounce here, and then I can bounce over here, and then I'm going to bounce back, and here, and over here. I'm going to bounce all over the place. So as a liquid, I get the freedom, a little bit more movement. I go a little bit faster than a solid, and I get to have a little bit more fun. So now we'll get into a gas here in a second. As a gas, I get a little bit more freedom. I have all this space. So I'm a gas. I get all this freedom. I don't have to bump into anybody. This is all mine. So as a gas particles get to move all over the place. They have all kinds of freedom, and they can go wherever they want. They're not confined to anything. I could go down that hall, I could go down that hall, I can go anywhere, because I'm a gas, and I can do anything. So then we'll go to the next part, so hold on. So now we're going to go into phase changes of a solid, liquid, and gas. So you saw how the particles move. You're very familiar with it, or should be familiar with it. Now we're going to go into it. So I have drawn on this board the things that you need to see. So I'm just going to go ahead and put that up. So you'll see I have the beautiful triangle you should remember from last year. You have your solid, your liquid, your gas. I'm backwards. It's so backwards this way. So the blue, if we decrease the temperature, so if we go solid, solid comes down to gas becomes sublimation, across, gas into a liquid is condensation, and then liquid up to a solid is freezing. That's if we decrease the temperature. Now say we increase the temperature, this solid, so the gas goes to a solid, which is deposition, and then you go from solid down to a liquid, which is melting, and liquid into a gas, which is vaporization. So examples, solid into a liquid would be ice melting. Liquid into a gas would be that water turning into hydrogen gas and oxygen gas. Okay, and then gas to solid would be taking CO2 and cooling it down. It does not go to a liquid. CO2 goes straight to dry ice. So remember that dry ice that we played with. If we're going the other way, starting at solid, if we have CO2 and we warm it up, it goes straight to a gas. It misses the liquid phase. It doesn't even go. If we go from gas to liquid, that would be at nighttime when the water molecules in the air that are gas cool down and become dewdrops on the leaves. That would be that. And then liquid into solid would be the liquid of that dewdrop freezes overnight and becomes either snow or becomes ice or frost. So those are your triangles. And then of course, these should look familiar, our heating curve. So we have our heating curve at 1 atm pressure. You start off with a solid over here, and you go up, and at 0 degrees it starts melting. And that's where the solid and it's a solid and a liquid at the same time, and they are at equilibrium. Then from there, you increase, you have liquid, because remember how it takes forever for it to get hot enough. Once it's at 100 degrees, it's going to boil for a very long time. Remember, that's where the liquid and the gas are at equilibrium. It's both a liquid and a gas. If you remember last year when we boiled the water, it took forever, but you could see the gas, and then the last phase is all of the gas. So this is your heating curve. Now, likewise, we can go the reverse, and we have the cooling curve. So then we have the cooling curve that looks exactly the same, except for its reverse order, starting with gas, going down to condensation, going down to liquid, then to freezing, down to a solid. So this is no different than the heating curve. It's just backwards. And again, these are at 1 atm pressure. If the pressure changes, then that heating curve and that cooling curve looks a little different, which you noticed last year when you were doing water and you were doing ice and boiling and all that, it had changed all that. So that's the end of solids, liquids, gas, plasma, phase changes. So then I'm going to go into the next topic with the next video.